So here it is. We're going to look one more time at the unit circle. I know there's an assignment that you have worked on it, but in fairness to all of you, what happened last class, everybody worked so well on the Desmos that I really didn't want to interrupt you because pretty well everybody completed most of the Desmos, which is great. And so we didn't really get to debrief these because of time, but a lot of you got into it. So we're going to talk a little bit about that. We're going to do one of our Jamboards, and this time we're going to do the anatomy of a sinusoidal function. We're now in sinusoidal and trigonometric functions, sinusoidal functions, meaning we mean sine or cosine. And then we're going to do a little debrief. And then we have a very interesting activity that I hope you will find interesting called Desmos graphing sine and cosine, which will connect some of the things that some of you know, and hopefully will clarify or expand or will explain to you things that are new to you. Okay, and then we will just briefly talk about the update of evidence records. If there is anything I want to say about that is don't sweat submitting stuff late. Submit it when you can. Submit it because that obviously builds evidence. And so I updated stuff, and I'm going to keep updating. Thanks to all of you who responded and who've told me you've updated things, because that helps me. Then I go back and review them, right? Because when I put it on the evidence record, then I kind of am done, and then until I hear from you, and then we can keep reviewing. So cool. All right. So let's go to our unit circle. Okay. So this is what the activity that you worked on last, or some of you have started. And let's talk a little bit about this. It's a very basic idea. And let's just review it very quickly. So we have here a slider that creates an angle that goes all the way from 0 to 2 pi radians, or 360 degrees. And what we have, this is actually one of the most lovely mathematical tricks ever invented. And sometimes mathematicians are so good at simplifying something that could be more complex into a beautiful idea. And this is one of them. This is the unit circle. And the reason, probably all of you know this, but in case you didn't, the reason it's called the unit circle is because the radius measures 1. So the radius is a measurement of 1 unit. If you notice in the graph here, I have the 0, 0, and then I have 1, 2, and so on and so forth this way, and up 1, -1, -1 this way. So what is the implication of this radius being 1? Let's talk about this in a moment. So let's build a little angle here. Okay, so right now, this is what we have. We have an angle that measures, and this is a really nice little applet, pi over 12. You can think pi over 12 radians, or 0.083 radians. And what we have here is this. Let's analyze the 3 ratios that we have. If we begin with a cosine, I hope you remember that the cosine is, the definition of the cosine is the adjacent divided by the hypotenuse. So in this case, the adjacent is this red line, the hypotenuse is the green line, and guess what? That's the radius. And didn't we say that the radius was 1? So what this does is that all I need to know to figure out the cosine of this angle is to know the value of the x point here, which happens to be 0.966. And that's where this is. So this circle simplifies every possible angle in a very nice way, because the trick of making the radius equals 1, now we know that every time we divide by the hypotenuse, we're dividing by 1, which kind of cancels it out. And the same idea now for the sine. The sine is the opposite, which would be the blue line, divided by the hypotenuse, which now we know is 1. So that tells me the point that I have here, the y value of my point, is equivalent to the cosine. How cool is that? And of course, then I can expand that and realize that I can look at it this way. The tangent, here's our Braden, the tangent is the opposite divided by the hypotenuse. Well, didn't we just say that the opposite was the sine? And the, sorry, I said opposite by hypotenuse. I meant opposite divided by adjacent for the tangent. So the opposite, we said, was the sine, and the adjacent, the cosine. So we uncover something that many of you already knew, that the tangent, in addition to being the ratio of the opposite to the adjacent side in a right angle triangle, it is also the ratio of the sine over the cosine. So in this little circle, we embody tons and tons of trigonometry. And as we move our slider to increase the size of our angle, this is updated. So now I can see here that I have pi over 4, or 1/4 pi radians, pi over 4, which I have the cosine here, and the sine. Actually, they happen to be the same value. So this is equivalent to what pi over 4, isn't that 45 degrees? We knew pi is 180. Half of pi is 90. Half of that would be 1/4 of pi, which is 45 degrees. And I have sine, cosine, and look at this, the tangent is 1. So very interesting. And of course, the last thing, or not the last thing, but one of the other things in this little construction is that rule that many of you have memorized as to the sign of the basic trigonometric ratios in each quadrant. Here, I can see that both sine and cosine are positive. So if I divide, say, the sine by the cosine, I end up with a positive number. So anything here is positive. And you know where I'm going with this. We're going to cast something interesting here, by the way. And this is something that will also help you memorize or remember things easier. I'm not big on memorization, but more on thinking. If I know that the sine is the y value of my point somewhere, and the cosine is the x value, when I look at this angle, look at the coordinates of this point, 1, 0. So this tells me that the angle that I have is 0. Therefore, the cosine of 0 is 1. And the sine of 0 is 0. And then when I go to pi over 2, or 90 degrees, my coordinates are 0, 1. So what that tells me is for this angle, which is a right angle, the cosine is 0 and the sine is 1. And of course, now I'm in the third quadrant. The value for the cosine, you can see here, is negative. I'm going to divide these by, these will always be positive. So my cosine is negative, the sine is positive, but because I'm dividing these two, I'm going to get a negative outcome. And that's the cast rule that many of you have memorized. So when I come here, now my coordinates, my angle is pi radians, 180 degrees, and the coordinates is negative 1, 0. So the cosine of pi is negative 1, and the sine of pi radians is 0, and so on and so forth, right? I can go here in the third quadrant. Both cosine and sine are negative, but when I divide them, of course, I get a positive value, so the tangent is positive. And the same thing here, my coordinates at 3 pi over 2, so this is 1/2 of pi, 2/2 of pi, 3/2 of pi here, or 270 degrees. Cosine would be 0, sine would be negative 1. Very, very lovely construction, very interesting. So we're going to connect this to our next bit of learning, which is what happens when we start graphing these things. So in other words, imagine that on the x-axis, we are going to have the measurement of an angle, of all the angles possible. And on the y-axis, we're going to have either the sine or the cosine value. And what does that look like? Many of you already know what this looks like. You're familiar with it. It's a very common graph, and it looks like this, right? So what we call, in this case, is the sine function. Not, they don't look the same, all of them, of course. So let's make a quick connection between our circle that we just saw and these graph. Okay, so let's take a look. We said here we were going to put the angle. So here I have values, and I like this in GeoGebra that I can put my angles in radians. If you notice here, pi over 2, pi, 3/2 of pi, and 2 pi. So this interval from 0 to 2 pi is one loop, one going around my circle here, from here all the way around. Yes, that is one cycle. Obviously, you can see that this function repeats forever. These functions, therefore, are called periodic. They repeat. They have a period. That means, I won't tell you what the period means because I'm going to ask you that after, and I don't want to give it away. But they do have a cycle that repeats. So this is the basic function. And if we notice here, the sign, we said the sign at 0 is 0, right? And then it begins to get bigger. Look at the value of the sign here, just the blue, how it gets to 0.259, 0.5, 0.7. It increases until it reaches the value of 1 here, right? When our angle is 90 degrees, or pi over 2, which is this point here, right? Pi over 2, that is our value. And then it begins to decrease again until it goes to pi, and then it becomes 0 again at pi here. Yeah, does that make sense? And then we can see here is going to go from 0 is going to be negative. Yeah, you see this value, and it's going to go all the way to -1, which is what we see here. So we started at 0. At pi over 2, it went up, reached the maximum, and then it went down to pi, again, a value of 0. And then at 3 pi over 2, or 270 degrees, is -1. And then it goes back again to 0. And then we have completed one cycle of these sine function. The formula, or equation for the sine function, sorry, I don't mean to scare you with this stuff. Don't worry about anything else, but just look at this, sine of x, right? Sine of x. And just like other functions, you're going to play with some things that will happen when we change some of these values for our sine function. So for example, if I were to add 2, what would happen? If you want to make a prediction, put it on the chat, or you can just tell me. I'm going to add 2, and look what's going to happen to our function when I press enter, of course. Whoa! It jumped up, right? It jumped up 2 units. Interesting. What happens if I put something inside the bracket here? What if I go something like negative, and I'm going to go pi, because this is in radians. Let's see if it works. Pi over 2. I don't know if it will work. It did. GeoGebra is amazing. So take a look here. Do you notice what happened? How this was the starting point before. I'm going to make it a bit bigger. Yeah. Now it shifted. This is obviously a horizontal shift, and it shifted pi over 2 units to the right. In terms of sinusoidal functions, all these transformations have special names. These horizontal shift we actually call a phase shift. The phase meaning that where does the when do the zeros begin, and how does it go up or down? Good. So now I'm back to my original thing, and all kinds of strange things are happening because I was playing with it. But then I'm going to explore what happens when I put a number in front of the sign. And many of you do know what happens. Oh, excuse me. What if I put a number like 3 in front of this sign. Whoa, what happened? It got taller, right? It elongated. In other terms, it would be a vertical stretch. In this case, we are changing the amplitude of this function. Conversely, if I were to change this number and make it smaller than 1, like 1/4 or 1/3, what would happen? Oh, my function gets smaller, right? The amplitude decreases. And then the last potential thing that we're going to explore is something very interesting that is related to the periodicity of this thing. Let me see. I'm going to hide this friend. Okay, and then so right now you can see that to complete one cycle, this from 0 to 2 pi is one cycle, and after that is basically the same thing, right? It repeats. It's a wave that repeats. So right now, this distance that it takes for one cycle is 2 pi, right? Because we're all in radians, we're not in degrees anymore. And what happens when I change that? I know that the original is 2 pi, but then what if I were to do something like this? If I put a number like a 4 here and see what happens. What happened? Take a look at what happened. If you just look at visually what happened, it looked like the wave got closer together, as it were. And now one cycle, it's taking less, right? It's coming here. It's taking maybe 1/4 of what it took before. Yes. So the cycle got smaller. Okay. We're going to play with that in a little bit. I just wanted to kind of go over it a little bit. I don't like to lecture like this too much, but this is our basic function. Okay, and I know many of you do know a little bit of the basic function. So we're going to go next to our D2L. Excusez-moi. Let's see. And now we have day 19. So we're going to do our classic Jamboard. It's very friendly and it won't take long. And then we may talk a little bit about it or not. I'm going to tell you what the Jamboard looks like. And then we're going to go into teams, etc. So here's our basic sine function, like we talked about. What I want you to do, this is kind of a recall, see what you know kind of thing. So I want you and your partner or partners to give me the key characteristics of this function. As many as you know, as many as you remember, or if there's some that you don't know and you don't remember, put a question and say, I don't remember what this means. I know I heard the term, but I don't know what it means, okay? So let's get our groups going. So I'm going to, this is where I messed up last time. I'm gonna stop the share. Okay, so we're gonna do a brief summary of the anatomy of the basic sine function from the Jamboard. And this is team 3. The other teams did very well, but we're going to just go over it rather briefly. So we already talked about the shape that is periodic, that repeats every so often. And here are some key characteristics. Amplitude, which is the distance between the central axis of the function to the peak. So this distance here is called the amplitude. The period is the distance on the horizontal axis that it takes for one cycle to be completed. So in our basic case, this is 2 pi. Y-intercept is at 0, 0. And these being the basic function, f of x equal sine of x, there are any compressions or stretches or shifts up or down or phase shifts. So it's the basic function. The domain is any real number. The range goes from -1 to +1, which also highlights that the maximum and minimum points are at 1 or -1. And the last concept is that one of the frequency. And the frequency refers to how many cycles happen per unit, usually unit of time. And this is the reciprocal of the period. So in this case, the frequency would be 1 over 2 pi. 1 divided by 2 pi is the frequency. The unit actually is called a hertz when we use time. So, and that's the most common usage for frequency. So these were the key characteristics of the basic sine function. The cosine function has a very similar look, except there's a phase shift of pi over 2 to the right. But if we look here at the orange function, we can see the shape is the same, range, domain, everything, except that it begins, we can say begin. The point that was 0, 0 for the sine function is 0, 1 for the cosine. So it begins at the maximum, whereas the sine begins kind of the midpoint, but the rest is the same. So we can think of these functions as we can express one as the other just by a transformation. So if I had the basic sine function and did a horizontal phase shift of pi over 2 units to the left, to the right, it may end up to the right, excuse me, it would end up here, right, to the left, excuse me, sorry, pi over 2 units to the left, it would lead me the sine function to move here, and then it would look like a cosine. And if I had a cosine and I shifted pi over 2 units to the right, it ends up looking like the sine function. So for this reason, usually we focus on one of them because we know we can represent the other with a simple phase shift. Okay, and then after this, we have an assignment to do that is already in the D2L. And as usual, you can find it under assignments, or if you wanted to find it faster, you come here and the assignment is called Desmos graphing sine and cosine. You will follow this and it will take you to the link that will in turn open the Desmos activity for you, and you can just join in. You don't need to remember the code. And thanks to everybody who came to class, because you work very hard again, and most of you who came to class advanced quite a bit. So, which is good news because that is one of the few assignments that we have left. And that's it for this class. Thanks a lot for watching, and we will see you next Wednesday. Have a good weekend.